Hello everyone, this is Lian Marie Barangco of BS ECE 3C and for Communications 2 or ECE 23. We're going to discuss T flip-flop in this video. So T flip-flop, where T stands for toggle. T flip-flop is similar to JK flip-flop, only that in T flip-flop, both the inputs in JK are connected. So this is a circuit diagram of a JK flip-flop where we have inputs K and J with the pulsating clock input. We also have Q and Q bar as an output, where the circuit is composed of two AND gates and two NOR gates. So compared to this T flip-flop, we only shorted the inputs J and K and replaced it by input T. Also with the clock pulse and same circuit components with same outputs. It is received by relating both JK inputs, and when T is equals to 0, both the connected AND gates are disabled, makes it no change in the output. And if T is equals to 1, the output toggles. So for more thorough explanation or circuit for the JK flip-flop and T flip-flop, we're going to use 4 NAND gates. So it is still the same connections, except for we are using 4 NAND gates in this circuit. So in JK flip-flop, 2 inputs, which are the J and the K with a clock, and in T flip-flop we have 1 input which we shorted the J and the K inputs into T with a pulsating clock input. The outputs are still the same, which is the Q and the Q bar. So now for our truth table. So first, if the value of our clock, or if the clock is connected to the ground or at low 0, regardless of the value of the T, either high or low or 1 or 0, the output would be on hold. And if the clock value is 1 and the T is low or 0, the output would still be on hold. However, if the value of clock is 1 and the value of T is 1, the output will toggle. And for the characteristic table, so first, if our T is 0, the present value and the next value would still be the same with each other. So if T is 0, the previous value would only be copied by the next value. As seen here, if it is 0, then the next value is 0. If it is 1, then the next value is 1. And if the T value is 1 and the Qn or the present output is 0, the next output would be 1, which we can see the connection in here that Q next or the next output is just the complement of the present output. Next is the excitation table. Excitation table is based on the previous tables, which is specifically the characteristic table. So if the present value and the next value would be 0, 0, the T would be 0, as we have seen in here. And if the present value and the next value is 0, 1, the T would be 1. If the present value and the next value is 1, 0, the T would be 1. And if it is 1, 1, then the T would be 0. So for the logic symbol of T flip-flop, in this block diagram, we have here 2 outputs, which are the Q and the Q bar. We have inputs T and the pulsating clock, which has a small triangle and a bubble. So now we're going to proceed into our circuit simulation. So back to our circuit simulation. of the T flip-flop, we have here our inputs, which is the shorted J and K terminals before, but now is replaced by the T terminal. Our Q and Q bar outputs, the T terminal, and our clock, pulsating clock terminal. This is our source or the VCC, and this is our ground, which represents the low power, and this represents the high source or high power. We have here our NAND gates. So our T or the toggle is represented by A, the clock is represented by B, and the C and D is represented by our preset and our reset. So as I turn on the simulation, all the switches are connected to the ground. So the first thing that we should do is compare this to our truth table. If the clock is at 0, and if the toggle is at 0 or is connected to the ground, it means that our output is on hold. So output is on hold. And if the clock is 0 but the toggle is on high or is at number 1, it is still on hold. So it is correct. So as we can see, it is simultaneously blinking. So if C and D are connected to the VCC, the output or our probes are blinking. Thus, they toggle and they keep on toggling. And if we set C on low, only Q is on high. Turning on the toggle input as well as the clock, so we're going to turn on switches A and B, then the clock off again, so B off again, and set the C back on high. So we can see that the toggle D and C are all connected to the VCC. It is except for the switch B or our clock. Let's see what happens to the output if we turn the clock on alternately every time we switch the clock from high to low. So what will happen? So as we notice, nothing is happening if we switch the clock or the switch B from 0 to 1 or from high to low. And now what will happen if we set the clock to high and switch letter A or the toggle from high to low? So our output toggles. Now we're going to check this with our truth table. If the clock is at low and our T is at low also, then the output is on hold. And if the clock is 0 or is connected to the ground and our toggle is at high, it is still on hold. So no matter if we switch the value of our T from 0 to 1, the output would still be on hold because the clock is set to 0. If we set the clock to 1 and it is going to be connected to 0, the T, then it is still on hold if T is equal to 0. However, if the clock is connected to 1 and the T is at 1, then it will toggle. 1, toggle, 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 and toggle. So that's it. So every time we switch the clock and the toggle from high to low, one of the outputs, which are the Q and the Q bar, are at high state and thus indicates it is on.